Assalamu alaikum everyone and good morning. So we are here with another section of the chapter 4. We discussed last week about the finding the central position in the data, where we discussed about the mean, median and mode in the grouped and ungrouped data. So today we will be discussing about the some other aspect of the data. Again, you can say finding the different kind of the structure in the data. So the next thing that we will be discussing about the measure of the position. So normally we can deal with the different kind of the position that the data may have. The one position we can call quartile. Quartile mean 4. So it means the data can be divided into the 4 equal part. Decimals. It means the data can be divided into 10 equal parts. Our percentiles, our data can be divided into 100 equal parts. So it is a percentage of the data. Decile is the 10th part of the data, 10 equal part of the data, and the quartile is the 4 equal part of the data. So today we'll be discussing about the measure of the position to determine the position in the data, maybe in the quartile, that equally 4 divided 4 part. Our decimals are 10 equal part, our percentile are 100 equal part. So quartile is that there are 4 quarter in the data. The first quarter, if you take the you can say, if you divide all the data into quarter, it means 25% of the each data. So it means the first quartile have the 25% of the data, first 25% of the data. The second quartile have the median or 50% of the data. Third quartile, which is considered to be the 75% of the data, and the final, which is actually the 75 to 100% of the data. For example, we have a data that is actually given in example 12. We have odd number of the observation, and we want to form the quartile 1 and quartile 3, because the central quartile is always a median. Because it is a odd value, so we can equally divide the data between two parts. Like you can say, if you have the data that as given in the example 5, 10, 8, 6, 6, 8, 6. So if we arrange the data from the lowest to the highest value, so we can find the central value is 6. Because 3 values are there before the 6 and 3 values are there after the 6. It means that is the central part. So we are actually looking for the first quartile, which position or which number actually represents the second quartile and the third quartile. So the formula that is available to us, that quartile Q1 is equal to I into n plus 1 divided by 4, because there are 4 equal part. So the I is the position of the quartile. If it is 1, so we call we can multiply with 1. It is 3, so we multiply with 3 or 2 or 4, whatever it is. N is the total number of the sample or the data point that are available to us. So how we can find Q1 or the quartile 1, n plus 1 but divided by 4. So n is 7 plus 1 divided by 4, it is 8 divided by 2, so second position. So second position is attained by the 6. It is 25% of the data, the number 5 and 6. We would like to measure the third quartile, that is Q3, because here I into n plus 1, so I is 3, n plus 1 is 7 plus 1 divided by 4, so it is 8 multiplied by 4, 24 divided by 8 into 3, 24 divided by 4, so that is 6th position. So the 6th position is 8 of the number. So the Q1 is located on the second position and Q3 is located on the 6th position of the data. Okay. So similarly, there is another example when the data is even. It means the data is not actually equally divided. So simply we need to arrange the data. So after arranging, so what we need to do, so we need to actually determine the quartile Q1 n plus 1 divided by 4, so similarly 8 plus 1 divided by 4. So that is 2.2 position. It is actually between the 5 to 6 position. So that is maybe 5.25. So in this way we actually measure the position. Okay. Similarly, if we are looking for the third quartile to be measured, so that is 3 into n plus 1 divided by 4. So 3, 8 plus 1 divided by 4. So that is 6.7th position. So 6th position data plus 0.775 into 7 minus 6. So that it comes at 9.5. Okay. So it is for the group data. What if we have the ungroup group data? Sorry. So like the case we have where the 50 respondent are actually there, so we already have the class or cumulative number available, cumulative frequency available. So the formula we used actually n divided by 4 for the quartile 1, quartile 3, 3 n divided by 4. So it means the first of all we need to understand where the first quartile lie in the class of the data. So it actually gave us the 12.5. So it means 12.5 come in the second class, 21 to 34. Similarly, Q3 or the quarter 3, that is comes in the 37.5. So it comes in the data that is 49 to 62. So in this way it actually give us a class. So then actually finding the class, so we can take the lower quartile, it means the lowest value, then actually the n divided by 4 minus 8 means the frequency that are available divided by the 11. 11 is the total frequency in the data, multiply by 14. So in this way we can actually estimate the quartile for the Q1 and Q3. So the Q1 quartile is 26.23 and quartile 3 is 56.2. Okay, another thing that is very important in the data that we need to measure, variation. Variation means that the difference or the vary the data have within the data. It means how much data vary within the data point available to us. So variance is a kind of parameter that attempt to describe the variation between the variable or the data that is available to us. So normally we have the three type of the parameter utilized to understand the variance: range, variance, and standard deviation. So variance is actually for sample is actually described as S square, standard deviation described as S. So mean as X bar, and the number of observation at a small n. And for population is mu2 and then square, then the standard deviation, then the mu is actually represented with the mean, and the capital N is for the population number of observation. So there are first thing range. So range means the starting point and the highest point, and lowest point and the highest point. So it can be described as a range. So range is maximum data entry or data point minus minimum data entry or point. So for example, on the example 9, so we have the data for the corporation, the salaries data for the corporation A and the salary data for the corporation B. So the data points are there, and then actually we need to describe the range. So range means the maximum and the lowest. So the easiest way that we actually arrange the data. So after arranging the data, what we know, the highest number is 47 and the lowest number is 37. So what is the range? What is the difference between the 47 to 37? 47 minus 35, 37, that is 10. So similarly, we can do the same thing or finding the range for the corporation B. So the lowest data point that we have, that is 38, and the highest data point that we have, that is 47. So in between there is a range, so we can find a range for the data company B. Variance and the standard. So we discuss the range, then the variance and the standard deviation. So standard deviation for the uh, population and for the group data, that is actually available in the x minus mu, or maybe you can say we can actually divide the every x from the mean of the population, then divided by the number of the population, so that actually give us a variance. So in the group data and the ungrouped data, so there is a description that is available, the formula. Okay, so there is an example that starting salary given in the example 9 are the Kota Baru branches of the corporation A and B. Each corporation have several other branches, and the CEO plan to use the starting salary for the Kota Baru branches to estimate the starting salary for the larger population. Find the sample variance and standard deviation for the starting salary of the Kota Baru branch. So we already have the data. So what we need to do, all the data point that we have, we need to actually scale. Again, your x is available, so we actually need to have the summation of x, that is 405. The summation means plus all the values of the data, then the x square. So we need to take a square of all the values, and then actually we need to sum up all the squared value, that is 17,311. So s square is equal to 1 divided by n minus 1, summation of x square minus summation of x and square, and then divided by n. So here one how many values we have? 10. So 1 divided by 10 minus 1. So square of the x are the all the values square, that is 17,311. X is 415 and its square that comes at 172,225 divided by 10. So when we count, so that's value come 9.83. So that is actually the variance. And standard deviation, take a square root of it. It means you can say eliminate the square. So when you take the square root of it, so the value comes 3.1. So it means that is standard deviation, and the first value that comes as a s square is the variance of the data. Okay, so for example, we can actually find the data, the variance and the standard deviation for the corporation B or the branch B. Okay, so here when we have the group data, how we can measure the variance and standard deviation. So again, example that we already have for the 50 frequency. So we need to take the frequency and then the x, and how we can evaluate, take x square, it means multiply x with the x so that we can get the x square, then multiply frequency with the x, and then actually take f x square, it means the x square multiplied by the f. So all the value that we have, we need to multiply and then take a summation or total of them, then put the values in the formula, that is 1 divided by n minus 1, summation of x square minus summation of fx square divided by n. So it is the same for the group data. We don't use the frequency in the ungrouped data, but for the group data we use the frequency. So for putting the values in the formula, so the values we have 1 divided by 50 minus 1, 110181 minus the square of the fx, and then divided by 50, so value comes 419. So that is the variance within the data. So standard deviation for the data, that is 419, and taking a square root of it, and the values come 20.48. So this is for grouped and ungrouped data, evaluating the variance and standard deviation. So simply there is an example, so you can actually try it and try to understand what are the variance and the standard deviation. Okay, so after completing this, we need to understand, so there is a kind of shape or distribution shape that come forward. Distribution mean how the data values are look like when they comes together. So there are two division or two shapes that can become across that as a researcher, symmetric, non-symmetric. Symmetric mean the variance is uniform and it look like normal or bell shaped. Otherwise it is considered or look like non-symmetric, which is non not having a normal shape and normally have a maybe uh, merged or skewed on left or right side. So if you go on the slide 44, so it give a uniform kind of the entry where all the frequencies are equal, so it means it is a symmetric but uniform. But normally we don't have this kind of the data, but normally you have the data as described in the slide 45, that is normally distributed where mean and mode and the median are close, so it is called normal distributed or symmetric data. And the bell shape, bell shape means the central values are high and the start and the end values are a bit less. Similarly, when the data is actually skewed maybe right or left, so it means the mean is actually less than median and median is less than mode, so it may be skewed right. Maybe it may be not bell shape, maybe you can say segregated in a different way and actually more inclined toward right or left. Then otherwise, when the data is actually quite skewed on the left side, so it means the mean is more than the median and median is more than the mode, so it's skewed left, it means it is not normally distributed. Okay, identify the shape of the distribution. This is an example for this chapter. Identify the shape of the distribution from the previous example where mean is 42 0.34, median is 40.469, mode is 40 into 10. So mean is higher than the median and median is higher than the mode, so it means it is right skewed, otherwise it may be left skewed. So from the median and from the data we can actually identify the shape of the distribution. So there is an example that is available and we need to actually identify, it is a group data, so we can identify the shape of the distribution by taking the mean, median, mode and what kind of relationship that exists between mean, median and mode. Okay, so that's all for the day. So I will be uploading a sample question for this chapter 4 so that you can practice, and the next week we will be having our regular class face to face, inshallah. So that's all for the day. Take care. Assalamu alaikum and goodbye for now.